All right, hi you guys. Today I'm going to do a short lesson with you on how to work with literal equations. In other words, how to transform literal equations. When we transform an equation, it is really just rearranging the equation or the problem, okay? A literal equation is the same thing as a formula. It's an equation that contains two or more variables. For example, all of these formulas, which you should be pretty familiar with, are considered to be literal equations. D equals RT, rate times time equals distance, right? That's our distance formula. A equals BH, that's our area formula. V equals LWH, length times width times height. That's a volume formula. And P equals 2L plus 2W. That's our perimeter formula. A few of these we've actually used even very recently. So these are all considered to be literal equations. Literal equations, in other words, are the same thing as formulas. Okay? We're going to be working today to rearrange literal equations. And I want to start with something that should be really familiar to you. I want you to think about just a really basic equation. Let me redo that. Really basic equation like 4x equals 20, okay? Basically what we do when we solve an equation is, as you know, we isolate the variable. So what we're trying to do is go, well, how do I get x all by itself? Well, I know that to get x by itself, I have to divide to isolate it to give us x equals 4. These steps are the same steps that we're going to use today for transforming literal equations. And now let me show you how. Okay. What we're going to be looking at is this. Can we use formulas that are already familiar to us to solve for one of the other variables in the formula? So we're familiar with our distance formula. Distance equals rate times time. My question is this. How can we solve for rate or time? The formula is showing what we do to solve for distance, but what if I wanted to solve for rate? Well, let's see. If I use the formula D equals rate times time, distance equals rate times time, and what I'm trying to solve for is R, I want you to think about the same thing that we did when we were solving way up there for X. How do I get R all by itself? To get R all by itself, we're going to divide by T, right? That's going to cancel out our T's, but we know from our properties of equality that we can't just do that to one side. So we're going to divide both sides by T, and then we're going to simplify. And what we are left with when we simplify is distance over time is equal to R. The question asked, how can we solve for R? Boom. That's how we solve for R. We're showing what R is equal to. We're going to do the same thing to solve for time. So going back to our original formula, distance equals rate times time, think about what we're solving for. This time I want to know, how will I find T? Same steps that we did before. We're going to isolate the T, meaning we're going to divide both sides by R, and look at what we're left with. Distance divided by rate is what gives us time. So we've solved for time in stating basically that time is equal to the distance divided by the rate, and rate is equal to the distance divided by the time. Let's look at another example that you're probably already pretty familiar with, our area formula. We know that area is equal to base times height. So my question is, how can we solve for base? Think about what we're being asked to do. If we're solving for the base, we want to know, what is B equal to? I know that A is equal to base times height, B times H. I want to solve for B. So how am I going to get the B by itself? Easy enough. We're going to isolate it by dividing it by H. The H's cancel out. We'll divide by H. And here's what we're left with. Area divided by height is equal to base, or base equals area over height. Same deal, you guys, for solving for the height. I'm going back to my original formula, area equals base times height, and let's think about what we're solving for. I want to know what H is equal to. So I'm going to isolate the H by dividing both sides by B, and I've got area over base equals height, or height equals area divided by base. So think about what we're doing when we solve for another variable. What we're really doing is isolating the variable that we are trying to find. All right, hopefully that makes sense. And let's take a look at a few more examples. Here is exactly what we just talked about. So let's skip down to two new formulas. We've got here our volume formula. Volume is equal to length times width times height, and our area formula. I'm going to highlight what we're solving for. We're looking for what is H. So what I'm going to do in both of these formulas is I want to isolate the variable we're solving for, right? We know that solving for 8 means we're going to isolate H. So I'm going to my volume formula. Volume equals length times width times height. And I'm thinking, what do I need to do to get the H all by itself? Well, I need to get rid of or divide both sides by length and width. So I'm going to, in one step, divide by LW and divide by LW. These cancel out, and I'm left with H equals, right, height equals volume divided by the length times the width. Or you can have it in the original order, V over length times width is equal to H. All right. The next example can be a little bit tricky because that fraction, sometimes we're not really sure what to do. So anytime you see a fraction, we should understand that we need to clear the fraction or think about what the area formula really means. We know that the area formula for a triangle, I should say, is equal to, area is equal to base times height divided by 2. If I'm going to clear the fraction first, whether I'm looking at it as a fraction 1/2 or with that denominator of 2, I know that the very first thing I need to do when I solve multi-step equations anyways is to clear a fraction. So I'm going to start this by multiplying both sides of the equation by 2. These 2's cancel out, and I'm left with 2a is equal to base times height. I'm not totally done. I need another step here because remember what we're solving for. I want to know what h is equal to. So now I'm totally ready to isolate my h. So I'm going to divide by b to cancel those out. And whatever I do on one side, I have to do the same thing on the other. And look what I'm left with. 2a over b is equal to h. In other words, the height is equal to twice the area divided by the base. Okay? Even if you guys, I had done the problem in fraction form like this, my steps would still be identical. I would still multiply or basically distribute. Let me redo that. I basically would distribute the entire problem by 2, which would still leave me with 2a, right? I'm doing this, and I'm doing this, and 2 times 1/2, we know cancels out because they're reciprocals, is equal to base times height. And notice here, we have the same steps. So again, we're going to divide by b, and 2a over b equals h. Okay, so either way with a fraction, we're either distributing it or we are multiplying both sides using multiplication property of equality. All right, let's try another formula that you're familiar with. This is our perimeter formula. We are going to be solving, meaning isolating the W. So we're going to do this in a few steps. If my formula is perimeter is equal to 2 lengths plus 2 widths, I want you to remember that 2L is one term and 2W is one term. So I'm going to treat those really as just what they are, which is a term. I need to isolate, before I can isolate the W, I'm going to isolate the 2W, meaning I'm going to take 2L away from both sides. So I want to try to get the 2W by itself before I can solve for W. And here's what I've got. P minus 2L, right? I can't combine those. They're not like terms, is equal to, what's left on the right is 2W. Now I'm ready to solve for W. And I'm going to do that by dividing the right side by 2, right? That cancels out my 2's. And I want to divide everything on the left by 2 also. And I'm going to show you in a second another way that you could do this. But it's important for you to understand that when you divide both sides of the equation, you have to remember to divide all terms on that side of the equation. So look at what I'm left with. We're going to simplify everything down. P over 2, perimeter divided by 2, I can't simplify that down. But when I look at the term that shows me 2L divided by 2, notice that the 2's cancel out. So I've got P divided by 2 minus L is equal to W. And that is my answer. All right, I told you I wanted to show you this in another form also. So if I go back to the original equation, P equals 2L plus 2W, and I'm going to follow those same first steps where I'm getting the 2W by itself. I've got P minus 2L equals 2W. Here's a mistake, and I shouldn't really say that it's a mistake, but here are some steps that some students tend to take. We divide both sides of the equation by 2. So notice how that's different. And then oftentimes I'll have students leave their answer as P minus 2L over 2 equals W. And the problem with this, you guys, is that we can still simplify 2L divided by 2. So it is important for you to know that this here, this part of the expression is equal to P divided by 2 minus 2L divided by 2. When you've got this entire P minus 2L divided by 2 expression, we have to remember this means that both terms, P and 2L, are being divided by 2. And setting it up where you are actually dividing these up separately, I think is helpful as a reminder that, oh yeah, I need to still simplify those 2's. So we've got P over 2 minus L equals W. I hope that makes sense. All right, on we go. You ready for a really tricky one? It's actually not so tricky if you follow these steps. This is our formula for the area of a trapezoid. Area of a trapezoid is area is equal to half of the height times the quantity of the sum of the two bases. And we are trying to solve in this problem for the height. Okay, so hopefully you remember what I said on the previous page, which is this. We need to start by clearing the fraction. Easiest way to clear the fraction is to wrap the whole thing up and distribute. We're going to distribute the whole thing by that denominator of 2. And here's where this gets a little tricky. Although once you see it, you'll see it's not quite so tricky. We're going to multiply this and this entire term all by 2. And take a look at what happens when we do that. 2 times A, easy enough, is equal to 2A. When I multiply 2 times this whole thing here, the only change that's made is that 2 and 1/2 cancel out. 2 times 1/2 obviously are reciprocals and have a value of 1. So look at what I'm left with after I distribute. The only thing that changes is that I've gotten rid of the 1/2. So this is almost like it's one term and we are just canceling out the 2 times 1/2. The rest of this is really easy. B1 plus B2 is in parentheses. So all I need to do to get the h by itself is divide by b1 plus b2 and divide by b1 plus b2. These, goodbye, cancel out, and look at what we're left with. 2a divided by the sum of the two bases is equal to the height. That's a tricky one. I said it was tricky, and it is tricky. Okay? All right, next. The last thing we're going to go over today is sometimes we're not looking at like actual formulas, but we're looking at equations that have, look, this is the first time we are looking at equations that have two variables, which still makes these literal equations, because remember that a literal equation is an equation with two or more variables. In the equation y is equal to 5x plus 7, I want you to think about what you're solving for. We're solving for x, which means I need to isolate the x. That's it. This would be the same kind of problem as though we were solving a regular two-step equation trying to get what x is. So let's think about our steps. We're going to start by taking 7 away from both sides. When I take 7 away from both sides, on the left side I'm left with y minus 7, because I can't combine those, they're not like terms, is equal to 5x. I'm ready to isolate that x, and I'm going to do that by dividing both sides of the equation by 5. And look at what I'm equal to, or what I'm left with. I'm left with y minus 7 over 5, I'm over here now, is equal to x, or in other words, x is equal to y minus 7 divided by 5. Okay, I don't have any simplifying to do. If you think about what I said in that perimeter problem, another way to look at this is y over 5 minus 7 over 5. But I can easily keep it in this form here, what I just circled, because there's nothing for me to simplify. If the 7 and the 5 happen to cancel each other out, then I would simplify it like I did in the perimeter problem from before. All right, last problem that we're going to do here is we're solving in this equation for y. So I've got y minus 4 is equal to 3x minus 8. This is actually a really easy one, and here's why. All I need to do is get the y by itself. To get y by itself, I just need to get rid of that minus 4. So look at what we're going to do. We're going to add 4 to the left. We're going to add 4 to the right. And I'm left with y equals 3x minus 4 or 3x plus negative 4, either way that you want to do it. That is my answer. We're not really solving for anything. When you see the word solve, right, solve for y, solve for h, what that really means is rearrange, right? We're going to rearrange it to isolate whatever variable we're solving for. That's really all I've got for today. All right, thanks guys, bye-bye.